Hi, my name is Brianna. This is for calculus for derivative video. As you can see, my problem was f of x equals 7x arc sine of e to the x power. And in this part, we want to find the derivative of this problem. So of course, I'm going to write d over d of x to this problem to find the derivative. But also in this case, I'm able to separate both parts of the equation just by looking at the 7x arc sine of e to the x power. So I want to find the derivative of both parts because I believe I used the product rule. But I'm going to be explaining this from left to right. So on the left side, you can see basically just repeat what I already said. And I'm going to look at the 7x part first. According to my rules, the exponent is being subtracted by 1 and is also being moved to be multiplied to the number, which is be 7. Looking on the right side, I have 7x to d over dx equal arc sine of e to x. But from arc sine, I know there's a trig rule, so I'm gonna follow that rule and basically plug and chug. And I have 1 over the square root of 1 minus e to the x, and 2 will be multiplied inside of it, so I'm going to change that to 2x. And also the 7x and the e of x is being multiplied inside of it, so I'm going to rewrite that and put it on top of the numerator. Looking back on the left side, since 1 minus 1 is 0, you just get left with 7, so you have 7 arc sine of e of x, and you have the other part of the equation and combine them together to get the final part. This is the second problem, which is g of x equals square root of 7x divided by 3x plus 2 to the 5th power, and we want to find the derivative. But looking at the top part, we can simplify the square root of 7x by taking it to the 1/2 power, and you have to do that for both the 7 and the x. This is equivalent in both ways, just simplifying it. And we're going to rewrite this in the derivative form. And then we wanted to rewrite the equation following what I wrote below in the same steps, and also following the aspects of the exponents. You look at the 1/2 and the 5 times 2. Well, specifically the 5 times 2 because that's what is included in the original, not in the rule equation. But looking at the 1/2, we want to simplify that part by subtracting it by 1. And when you do this, you get 1/2 minus 2 over 2 equals negative 1/2. And you also want to simplify the 2, so you do 5 times 2 equals 10. And we replace that back into the equation. And now we have this, what is it called? Negative fraction as an exponent. And we don't want that, so we're going to change it and flip it into the fraction. If you understand what that means, if you understand what that meant, well, you can't have a negative exponent in the numerator of a fraction. So I flipped it, and now I have a fraction within a fraction, which looks really complicated. So I'm going to multiply it by 2x to the 1/2 to eliminate the top fraction and get left with 3x plus 2 to the 5th power, and also distribute the 2x to the 1/2 throughout the numerator and the denominator. So now I'm looking at a more simplified version without a fraction within a fraction. And now I want to look at the other part. It has, before I got cut off, it was u to the 5th, and this, you can use the chain rule. So 5 minus 1 is 4, and then move the 5 to the front. And I'm going to replace the u back in with a 3x plus 2, put it back into the equation. The d over dx, so 3x plus 2 on the other side, can be simplified down into moving the 3 to the front and the x minus 1, because 1 x to no power is an imaginary 1 right there, so 1 minus 1, and that goes away, so you just be left with 3. And derivative of 2 just equals 0, so 3 plus 0 is just 3. And we're going to take this 3 and multiply it by what's ever left over, which is the 10, I believe. So yes, that's 10, so you get 30x. And as you can rewrite the equation, and you have everything basically simplified out, and since I'm running out of time, you factor the rest of the equation out and get this answer.